Hello and welcome to the Azure A to Z virtual conference. This is the session on app modernization. I'm Brian Gorman. I'm an Azure MVP, a technical trainer, and you can reach me at blgorman on Twitter or Brian L. Gorman on LinkedIn. Also email brian@majorguidancesolutions.com. Thanks for being here for the A to Z app modernization session with Skill Me Up and Opsgility. Ultimately, this is a pre-recorded session, so just a lot of information being presented today. So this again is me, just a quick introduction. I am an Azure MVP, so I'm happy to be here to be able to support Azure events where we can actually talk about Azure and enjoy some of the things that it has to offer. And today we're going to talk about modernizing your application. But you see, I have a number of certifications. I am also an MCT. So if you need any information about how to get certified on any of these certifications you see here, or even other ones, please don't hesitate to reach out. I'd love to talk shop with you and be able to help you on your journey. Also, Practical Entity Framework Core 6, the second edition, was just released. So if you're interested in that, go ahead and check it out. So today we're going to start off by talking about traditional architectures and where we were in the past and some of the problems with that, and then why that would behoove us to make a move into app modernization. We're then going to talk about how we could go about planning our migration and some of the tools that are available to us at Azure with that planning, as well as why we would do it, some of the benefits we'll get. Of course, overcoming some of the things we'll highlight as issues with the traditional architecture. We'll then move into talking about various Azure Platform services for different types of frameworks, whether it's microservices, serverless, or just traditional applications. Even monolithic applications can be done in Azure Platform services. So all of that's possible. We'll finish up with a discussion on CICD. Now also, just a quick note, I have another session on Azure Web Apps. So if you would like to see a lot of this modernization actually applied, you would want to check out the Azure Web Apps, where I go through a demonstration of actually using Azure App Service and deploy that all out through the whole entire process. All right, so let's start off by talking about where we were, because in order to know where we're going, it's a good idea to know where did we come from. So traditionally, we had a data center, and the company was responsible for everything. And so you had a team of people. Sometimes you had a network team and an app team. Sometimes it was a one shop for everybody, and you were doing all the things. And so you had to be a jack of all trades. Now with this, you had a lot of control. So there were some really good things to having your own environment, because you're running the show. So you can set it up exactly the way you want it. But what if the way you want it isn't the way that John wants it or Sally wants it, and you're all in the same department? So there were those issues, but that's simple. You figure it out and you get it to work. But ultimately, at the end of the day, you bring on 10 more team members, and suddenly only you and John and Sally are the only ones that know what's going on. And everybody else is kind of like, those guys they're experts and they do everything. And so when things break, they go to you. When they need a deployment, they go to you, because pushing and praying with the application that you built doesn't necessarily always work the way it should. And sometimes that leads to really long nights and weekends of trying to get things to work in production. There were a lot of issues with this traditional data center just around the overall structure of it, but let alone with the ability to have that full control, the application management, all that stuff configured. There was a knowledge silo. And we just want to try to avoid knowledge silos as much as possible. On top of that knowledge silo and those issues we just highlighted, there were other things like the code actually being in a centralized repository stored in your data center, and often it would get corrupted. And it was a centralized version of code, so once it got corrupted, it was corrupted for everybody, which meant some way you need to figure out to restore that, and you may lose some code in that process. Additionally, there's usually, again, those one or two people that know what's going on during the deployment. And they typically expect everyone else to just be able to do it, even though there's things that they know just by attrition. They've been there for so long that they know the little secret things that could possibly happen, and they also just know the systems better. So you bring in a new developer or a new team member, and it doesn't have to be someone that's new to IT at all. It could be someone who has 15 years of experience, but they come onto your team and you've got these obtuse processes that they don't understand, and you can't really explain it, or not that you can't, and not that you won't even. It's just that you don't remember the little things that you know until you're in there. And so they go out to do the deployment, and the next thing they know, it's broken. They're afraid to ask you for help because it makes them look bad, or they just don't like bothering you, or whatever it might be. Long hours, downtime, lots of problems. Addition to all of this, deployments were typically, again, not automated. So that mystery was there, but it was some tool or some special process. And again, only one or two people know how that works, and you have that problem. All of that, development life cycles added into this. Now we have waterfall type of development cycles that were just very long, not a lot of user feedback until it was way too late in the process. We eventually started to move into Agile, but even people doing Agile were really just doing some kind of modified waterfallish, maybe some sort of iterative development, but not full Agile. Now it's gotten a lot better, obviously, but you can do Agile development in your traditional data center. So I'm not saying that you have to come to Azure to be an Agile team. No. That's not it at all. You come to Azure to get modernized, not to be Agile. You should already be Agile either way. So you had these long life cycles. It took a long time to get things into production. If something broke, you basically stopped development and had to fix that, which could take, a couple days and maybe set your development cycles back even farther. That makes some longer downtime for the app. A lot of legacy issues that continue to pile up because you don't have time to deal with the technical debt. You cannot keep up with the pace of technology. And so there's a lot of issues. On top of all of that, your applications were typically monolithic. Now that meant that you had a lot of uncertainty or even fear about making changes. Because what happens is you come in, especially as a new developer, someone that has actually never programmed a lot, so maybe 1 or 2 years of experience, or someone who's a new developer to the team, even from within the same organization. You might have one department over here doing one thing and another department doing another thing, so your left hand doesn't know what your right hand's doing. If you move teams from the left hand to the right hand, this job you loved at this company you loved might become the worst thing that's ever happened to you. And that's a really bad scenario to be in because you had this great job and great company and you thought everything was going to be great. You moved to a new job. The development process, the applications were completely different. You have this great big gigantic monolithic thing, and if anybody's afraid to make changes because the second you make any change, you just never know what you might break. And that leads to even more stagnation and inability to get things into production. It also meant moving to a new job, shifting to a new team could be a very, very discouraging ordeal. Or just coming into development as a new developer, in that job, you might be like, yeah, development's not for me. And it might not be because development wasn't your thing. It might be just the way that development was handled in that first place you were at. The thing about it is it all worked. Believe it or not, through all of that, it still worked. And we made it work. And it was great. And everything did work. But there's better ways to do it. And we're going to learn that today. Also, the traditional architecture at the data center was typically all physical bare metal servers in your own site or in a building just off-site that only a few people can get into. So this means that if something goes wrong, those few people are the ones that get called on every time. And out of those few people, again, 1 or 2 of them really know what's going on because you walk into the server room and of course everything is pristine. Every server is completely organized the way it should be on the right rack. All of the networking, the cords are elegantly weaved between each one so that you can easily see what goes where. And there's no tangled or shorted cords and certainly no RJ45 cables that can't stay plugged in because the thing's broken off the end. That never happened. Ultimately, yes, that happened. So you had all these things to manage. You had servers, you had networking, electricity, cooling, people, security into that building, into that room. You had compliance and licensing to worry about. Were you up to date on your licenses or were you just making it work somehow? You had backups, manual backups that you had to run. You had to maybe even sometimes in the olden days move a tape. And somebody's like, I still do this. But ultimately move a tape from one building to another. Now that could also mean having some sort of security around that. You might have to take an armored car just to move a backup tape from one building to another because of the data that's on that backup tape. Crazy, I know, but it happens or happened. Anyway, there was also support. And we've already talked about the 2 people that know what's going on, but then you rotate everybody else into support. They end up calling the 2 people that know what's going on if they have the courage to do that. It just leads to a really bad scenario of work where people just aren't comfortable. Nothing gets done because you get so discouraged, to be quite frank. That's happened to a lot of people. Some people love it. Some people thrive on that, and that's great for them too. Anyway, support rotations, long hours fixing issues, constant calls from users. So the idea being we want to get away from this. So let's talk about where we came from with the architectures. Traditionally, we had someone who was able to get into our application, typically through the internet, through some sort of firewall. Someone was responsible for maintaining that firewall, making sure we had a load balancer, which could be device or software based, routing traffic to the web server and some sort of balancing pattern, whether that's weighted or round robin or one of the network load balancing patterns that you could use. That goes to your web server farm. From there, you traditionally have another device or software that load balances the traffic from the web server to the database server. So that's your internal load balancer. And ultimately, all of this hardware had to be maintained, wired up correctly, authenticated correctly, ingressed correctly, IP addressed correctly. So you had admin people taking care of this all day long. And whether or not they were dedicated to that really generally meant how well they could do the job. And if you're not just dedicated to that, it's a lot harder if you're also developing. And a lot of shops are doing both. Again, jack of all trades. Now, it has worked very well for many, many years, but there's a gap when it comes to providing resiliency, failover, general recovery from disaster, such as hardware failure or data center issues, such as loss of power, or perhaps you have a backup that failed and you thought it was good and you need the backup and it's not there. So as such, moving to the cloud, where some of this was mitigated, along with changing cost concerns from capital expenditures to operational expenditures, has been an attractive move for many years. And that means you're basically saying, rather than pay for all this stuff up front and maybe use the hard metal server that we built, we can just provision this at Azure and only pay for what we need to use. So that was what we'll call a lift and shift approach, ultimately part of the cloud adoption framework. And I think Dwayne is talking about the cloud adoption framework if you're interested more in Microsoft's recommended strategies for moving your entire organization into the cloud. But ultimately, one of the patterns is a lift and shift. In that case, you would take what you currently have, and maybe you're in a hybrid scenario where you need to sync on-prem users with the Azure Active Directory users, and they are different Active Directories. Even though it's Azure Active Directory and Windows Active Directory, you did have to sync your users. Typically, your business users from on-prem would come in through a VPN gateway or an express route, hitting some virtual network, which is kind of the hub of the entire thing. The internet users also come in through the hub, and that's where you provision your firewall, and then you have a bunch of spoke VNets. And each of those spoke VNets has your different resources for different web apps and applications out there. And you can see that in the spoke VNet, we have a load balancer, just like we saw in the traditional architecture, hitting the web server farm with an internal load balancer hitting our database farm. So the architecture overall is not that much different than what you had in the data center. The difference is we're shifting responsibility from our people on-prem managing all of this to Azure managing at least the hardware portion. So if a network card goes down, or if the cable doesn't connect correctly, or if power goes out, we have other people at the data center worrying about that. All we worry about is what our IP addresses are and how we get into our networks, and then we configure all that. So we still have all that control. And in fact, if we use VMs for our deployment in this case, we have full control over those machines, just like they were virtualized on our own data center. We just literally said, we're going to use your hardware instead of ours. And we get elasticity and flexibility that comes with that. That means that I can spin up new instances. I can scale out, meaning adding extra VMs, or I can scale up. I can make one VM make much more powerful compute time. I might give it more memory or more disk space, whatever I need. That's scaling up and down. Scaling out, of course, is adding more instances. Either way, I only pay for what I use. So when I don't need load, I don't have to give it extra load. I can bring it back down to my minimal instances of VMs. So this was still traditional, but it is on the cloud at this point. So there are other considerations not shown here, mostly around managing your users, but there's other scenarios that you might encounter that are a little more advanced than just setting up a simple web farm and database farm that you can ingress into from the web and from your users. So just keep that in mind, but this is kind of a traditional lift and shift for what we have. But now, even we're in the cloud, we still have a lot of management on our own. We're managing VMs, we're managing the actual networking, all of that stuff is on our shoulders. Additionally, backups, resiliency, we have to create regional failovers, we have to test those and manage them. With the lift and shift, we still had some issues. So we need to figure out, is that our first step? Are we going to want to do a lift and shift as our migration? If we're coming from on-prem and we want to be up and running as quick as possible in the cloud, that's typically the path because it's literally plug and play. You recreate your environment, you point your applications at the tools at Azure via connection strings or whatever IP addressing you need, and they should just work because it's literally the same thing, just on different hardware. That might be really easy to get up and running, but you still have to manage your licensing. You still have to take care of all of the different resiliency things. Also with that, the licensing, you can use a hybrid benefit. So if you have currently purchased 3 or 4 years of SQL Server, it might make sense to use those licenses in the cloud and lift and shift provisioning for a while. This could also be the wrong approach. If it's overkill, for example, what if I just need to get a web app out into the cloud as fast as possible? Do I need to set up a virtual network with an ingress through a firewall, a web application firewall, into a new peered network so that I can have my Azure SQL database over here and my Azure Web App Service over here, or a VM with all of that, just to get a simple web page out there to the web? No, I don't need any of that. And in fact, that might be a reason to do a greenfield project and prove things out in an app service rather than trying to use one of your traditional monolithic applications. But ultimately, if you have a small application, it has a few needs. Maybe you're serving some e-commerce needs or user registrations or something very simple. You just need a public-facing website managing its own user authentication or potentially integrating with your Azure Active Directory or your on-prem or whatever it might be. You have the very important ability to just quickly spin up a new web application and delegate all the things like resiliency, backups, licensing, compute power, provisioning, all of that stuff to Azure. Now you can still control your level of service plan and you can scale up and scale out, adding more app service instances or adding more compute to your plan if you need it. And you can even automate that through alerting, but you can do it very quickly in a modern approach. So let's say you've decided though, you have a traditional web application with a server farm or with at least one web server in some VM or actual server on-prem or in the lift and shift environment, either one. And you also have a SQL Server on a VM. So traditional application, and you want to migrate it. You decided we're done with lift and shift. We're done with our on-prem. We're going to retire the data center completely, or we want to get out of the infrastructure as a service, IaaS, completely. We want to just deploy this out there. So let's say you want to do that. Great. Start an Azure migration project. And with the Azure migration project, you can point at your servers, detect what servers you have, and for a web app, even a traditional .NET Framework web app, for example, you can push a button and it will literally migrate that app into an app service on a premium tier so that you have a resilient application with compute power ready to go at Azure and literally takes the code that you had and makes it work. And so it's really cool. You can do the same thing for your SQL Server database. Now this has become a little more tricky with two-factor authentication, so there are some considerations there. At some instances I've found it may be just a little easier to actually just take a full copy backup of your application database, and then if you want to put it in an Azure SQL, you need to make what's called a backpack file. So you can do that through SQL Server Management Studio. Just import your backup and then export a data tier application, and then you can import that into an Azure SQL. So if you can't use the SQL Data Migration Assistance for some reason, it's still very easy to get your backups restored as an Azure SQL database. There's just a couple hoops to jump through. But if you can get it to work through the migration project, that's even better because it will literally copy the schema and the data and move it in, and you're good to go. So it also gives you an assessment, kind of talks about what you're going to do, and you have tools you download to your machine, the web app assessment tool or web app migration tool, as well as the database migration assistant. Of course, this does typically work better if you're already in Microsoft technologies. If you're in Java technologies and you're moving into an app modernization scenario, that is still entirely possible. You might have to struggle through a few more things if you're trying to use one of these migration tools. Otherwise, you can manually do things as well. So it's not impossible. And Java is fully supported in the Azure Workspace as well in app services. Ultimately, with an app modernization, you might even move things to a NoSQL database like Cosmos, which we'll talk about in a minute. Let's talk about the benefits then. Why am I moving into a modern approach? Because there's a number of things I'm going to get out of the box that I don't have to do a thing for. And you see a number of icons here. Those icons are specific tools at Azure, like the Azure Monitor, Security Center, Sentinel, Key Vault, Defender, and Application Insights. Now, you get the ability with the modern architecture to have all that in play. So you can easily add additional features to your application at Azure because things are going to talk to each other very easily. So you can add serverless components or microservice approaches. You can break up your monoliths and start building tools out. But you get the ability to use these tools that are built into Azure by default. You'll get resiliency on your applications. You'll get SLAs that guarantee you're only down for a few minutes a month, or even better if you do a few other configuration things. You're going to shift your cost. You're no longer going to be paying for things you don't use or rushing to get new materials because you ran out of compute power or whatever it might be. You'll pay for what you use in an operational expenditure approach rather than a capital expenditure approach. You'll get rid of the need altogether for any physical hardware and all the management, handling, powering, security of that hardware, all gone, all done at Azure. Modern approaches also minimize the need for administration then. Most of the underlying work is delegated to the Azure teams and the Azure data centers, so you'll have things like backups, patches, and licensing, as well as that resiliency built in. You may also do some more administration around that, but you don't have to. You also get built-in monitoring and alerting, along with flexibility and elasticity of that cloud-based solution. So if you're having a site that's getting overwhelmed by hits, you can spin up another instance. You have less traffic than expected, scale in or scale down to save cost. You don't have wasted hardware. You don't have any downtime getting to more powerful compute solutions, and you only pay for what you use. And finally, with the modern approach, you get all of these security benefits. So you have the Azure Defender, Azure Sentinel, Azure Security Center, which are going to give you recommendations. It's going to prevent things like denial of service attacks by default. It's going to add in things to give you recommendations. You can click a button to mitigate security issues, or at least give you instructions on how to mitigate them if you can't just click a button. And all this is monitored. You'll get alerting around it. You can set specific alerts to handle it even more efficiently if you need to. Same thing with scaling. You can build alerts to make sure that you're automatically scaling in or scaling out or scaling up or down as needed. And so you can minimize weekend work for your team because you have some things automated, and what little things do happen, you can respond very quickly. So different platform services, what's available to you out there? And this may be overwhelming, especially if you're just coming into Azure. So break it down into layers. What kind of thing are you trying to build? Are you building a traditional code application? Are you going to build a containerized application? So that should be one of your first choices, because based on that, that's going to determine the service you want. So if I'm going to build a containerized application, my choices are Azure Container Instances, Kubernetes, or Container Apps, which is a managed Kubernetes now. It's a brand new thing, so it's really cool. We're all kind of starting to learn about it. There's also a container registry at Azure, which stores your images, just like Docker Hub. And ultimately, you can then leverage those in your deployments. Now, you can use an app service with a container as well. And the cool things about that is, if you're familiar with containers, you know that they're immutable. And when that means is, if I have a connection string or somebody changes a password or something, I have to respin a new container to do that. With an app service, I can inject or override some of my environment variables from a container, so I don't have to spin a new container to change an environment variable like that. Now, once you have that, you have containers, you have your traditional architecture. If you're doing your traditional architecture, likely you're just going to be spinning up the app service, and that's going to just work for you, whether it's Java or .NET or whatever flavor. Maybe you're using some Python or something. You can do that in an app service. For your database, we have traditional Azure SQL. We have different ways to deploy that. That could be an on-prem type of lift and shift where we do a SQL VM and have full control. We can do the Azure SQL, which is the absolute opposite of that. We get the least amount of control, but we also don't have to manage things like backups. We can go ahead and have our Azure SQL out there and be able to do export data tiers. We can back them up that way our own, but they'll be automatically backed up, and we can restore from backup with a push of a button. The middle tier then is somewhere in the middle. If you need to have a little more control but want to have some of the platform services, look into the SQL managed instance. If you're using a non-traditional database, look at the PostgreSQL, MySQL, or MariaDB options that are available. If you want NoSQL, you can use Mongo or Cassandra. You can still import those into Cosmos DB, and it should be as simple as changing a connection string. You can also use the Cosmos DB, and so getting that set up is fairly easy. Additional tools for serverless are function apps and logic apps, and you have those available to you. So the next thing we're going to talk about is the microservices approach. Everybody's talking about it, and everybody wants to be microservice. And what does it really mean? Does it mean we're using containers or not? Does it mean we have interconnected systems with 5 microservices that are chained together? How does it work? What does it mean? Well, ultimately, let's talk about where we come from again and where we're going to. So monolithic applications typically have domain-specific functionality. They're normally divided into functional layers, like an in-tier application, where you might have web, business, data layers. You might have different tiers within that. You might have different things going on. But all of this together has to be together or nothing works. You scale that monolithic application by cloning it on multiple servers, virtual machines, and containers. We saw that as we saw our web farms and our server farms. So basically, to scale it, we needed another instance, right? A microservice application is going to separate your functionality into separate, smaller services. So instead of having all of your layers in one big thing, you can have the business layer doing one thing, but it maybe even its business-specific functionality for maybe 6 different services are the business layer. So those services combined make up the ability to do the same thing that that service layer did in the monolith. And now you can get faster development cycles, because ultimately I have to only move a piece of code to make my changes. And everybody's leveraging that instead of leveraging some library that one team modifies the library. Now we got to sync all the changes across all our monoliths and hope and pray again that it didn't break anything. Within the microservices, you should get immediate feedback because everybody's leveraging the same microservice. And if something's broken, they would know within a few minutes usually, and you'd be able to fix it. So you can very easily get a faster cycle time because now you're only changing minimal pieces of code. And the idea being, A microservice should not know what other microservices are doing, and it should not need to. It should only have a specific purpose. Just like a function, we say a function has a contract. That contract says, you give me this, I'll give you that every single time. It doesn't change, it's idempotent, it's immutable. That's what we want with microservices. We want to be able to be guaranteed if we give it the same input, we'll get the same result every time. Now we can also reduce costs, because maybe what we'll find is that we spin up some function apps or logic apps or whatever serverless technology we want to host some of these microservices. It could be container instance, whatever it might be. Any of those tools can be used. We may be able to really greatly reduce the amount of money we're spending because we don't need this gigantic server to host this gigantic monolith. We need enough functional compute power to run that function this many times a day, and that's it. So ultimately, we scale out microservices by deploying each service independently. We can create instances of those services across our servers, virtual machines, and containers, so they don't have to be defined within any boundaries. So there are different definitions of microservices, but most of the characteristics of a microservice are widely accepted. So again, those things I was mentioning earlier, think of it like this. Encapsulate the scenario. What problem are you solving? Make it small. You have smaller teams because you have smaller units of work. So now you can break your teams up into more granular control. Now you still might have 5 people on your team and they might be responsible for the whole monolith across all the microservices. That might happen. But if you're in a bigger organization, you might be able to get a little bit more granularity. And with that would maybe come just the ability to have more expertise in those sections and a little bit better, even faster cycle time with less mistakes, right? You can write them in any programming language. So if my monolith is all in C#.NET and I want to use Java, sometimes that's not so easy. But if I have microservices and I want to write a Java function and a C# function and a Python function and a function that's even done with PowerShell, I can do that. And my app can call them because it's just a web endpoint that I'm hitting. It's just an API. I don't even need to care what the underlying language is. It's completely independent. The code should be independently versioned, deployed, and scaled so that you can easily reference the version you need. So typically like an API, you might see a version if you have some dependencies on a previous version. That's not unexpected. Obviously, you want to manage that as much as possible because the least amount of versions you have to support, the better. But if you have no choice but supporting 8 versions, then that's going to be a little bit of a management issue. You can interact with other microservices over well-defined interfaces and protocols. So we're going across URLs. Maybe we're using TCP or AMQP or some other protocol to connect to these services, but ultimately they're well known and everybody should have some code that can do it in some place. You typically have unique names that are easy to resolve, so you can use that to also define more information about the microservice to help people make decisions. So it might be a location where it's hosted, or it might be the actual name of the microservice tells me what it's for. The microservices typically should respond well to failure and remain consistent. So we should be able to be idempotent. Basically, if I run that application and the microservice fails, I should be able to run the application again. The microservice should have enough grace that it should work to not duplicate things and make sure that it does pick up where it left off if possible, or at least execute in the same manner that it would have and not give me, again, mostly I'm concerned with things like duplicate processing or duplicate inserting so that I don't get numbers skewed or further issues created by duplication. So as I move to the microservices environment at Azure, you can actually use a tool called Service Fabric. It allows you to reuse existing code and modernize it with new microservices. There are 5 stages then in the application modernization, which is you start with that traditional monolith, you migrate it. So again, this might be containers, this might be Azure Functions, it might be Service Fabric. You can use containers or other executables to host your code in Service Fabric, but you can also just move to Azure Functions too if you want to, or logic apps, or whatever you need, a web API. You can modernize. So alongside of your move now to get your monolith into microservices, you're also going to modernize the code. You're going to update library references, trying to eliminate technical debt as you're touching the code. You might also be innovating, meaning you're going to try to take this application, instead of now having this function that was supposed to do 3 calculations, maybe you make 3 services that each do 1, and you can then innovate a new way to calculate at one of the stages and move much more quickly. You might also just innovate a new process altogether because of the new understanding of the architecture. Whereas before you had this long chain of events, you might have separate units of work, and that could be really easy to manage, harder to conceptualize as a developer and keep track of, but make some diagrams and make sure you keep track of that and you'll be better off. As you innovate and do that, the final step is transforming your application into fully blown microservice architecture. Sometimes that's just building a whole new greenfield application. Sometimes it's migrating pieces as you go. So reasons to do this, many companies are migrating because of the fact you can do the cost reduction. Either you consolidate or remove existing hardware, you run applications at a higher density. You also get a consistent deployment contract between the development and operations with this, because now I can easily, quickly spin up things and deploy them. I modernize as I go, allowing me to add new services. I innovate. I give me the ability to accommodate changing business needs as I go. So some drawbacks, state management is much more involved. Each of these has to manage its own state if you're using state. And side by side means you also have multiple versions. So version 1 and 2 might both be working in production. Which version do you use? Again, we kind of hit that with the API thing earlier. We want to make sure we don't break someone's deployment by eliminating a version. So we may have 8 versions we're supporting. The disconnected nature of the architecture can lead to very complex understandings of the work. It may make it slower for new developers to come onto the team. It may also make it slower to innovate because you have to consistently remind yourself of the order of operations of different microservices or which one is supposed to do what. So the better you can do with documentation on that and the better understanding and organization you can do around your architecture, the better that will be for you in the long run. This is the same with repos at GitHub, right? Or any solution provider. If I have one massive GitHub repo, it's very easy to find that repo, but then the code changes in that go very slowly. If I have 47 repos at GitHub, it's harder to find the right repo, but I can make changes without having to affect the 46 others potentially. So you've got to figure out what's your approach. Is this going to be the right thing for me? And taking those dependencies of the complex architectures into consideration. If you do it incorrectly, you can actually do this thing called a monolithic microservice, which is a really, really bad thing. So some people argue all the way down to the level of every microservice should have its own database, right? And that might actually be a very good, valid argument. It may not, but it might be. And ultimately, that would mean you are keeping things as separate as possible. So I kind of like it. By the same token, that means I got to somehow coordinate all these databases. That's what I'm talking about when you start talking about your dependencies. Which databases do I have to work against? Which application do I call first? Which endpoint do I need to hit before I hit the other one? And the endpoints shouldn't know what each other's doing, but your orchestration needs to know. So microservices, is it right for my application? Well, it might be. If you take things to a microservice-like approach, you can get a higher development lifecycle, so you can move more quickly, which may be really important to your customers. And so if that's important to you, that might be the right approach right there, and it may be worth the pain. And then the teams also find, as you work through this, that there are some hard issues you have to solve. So that can also lead to things like, now I'm creating problems that I don't know how to solve. This is outside of my wheelhouse. So you may have to bring on other experts or consultants to help you in certain scenarios, which can be another thing to consider. So outside of microservices, the other big buzzword when it comes to moving to a modern app is serverless. So of course we can do traditional web apps. And in fact, again, remember that I have another talk if you're interested. Go look at that one on the web app. That's a traditional app basically ported into the web. We did microservices. We're talking about moving these interconnected pieces and making everything work. But serverless is kind of like the bread and butter backbone of microservices architecture, because ultimately now what I'm saying is there are servers out there and they are hosting code, but I don't care which one it is and I don't want to know which one it is. It's your server. I'm just going to put my code on it and rent the space while I run my stuff. And so what ends up happening with serverless is you do get some really great benefits like low-code deployments, which means that I can quickly move a very small piece of code into my deployment. And it doesn't matter. I don't have to spin up a server usually or do some other kind of traditional deployment pattern. I just push the code into its instance and it usually just automatically starts working. Now, it may not work because I didn't do it right, but at least it should try to work. The other thing about serverless is typically it's burstable or consumption-based. So an Azure function with a consumption plan. You can even have Cosmos DB on a consumption plan now. You can have the ability to only pay for what you use. Maybe you only have a process that runs at month end to do some calculations. Spin up an Azure function to do the calculations and only hit it when you need to at the end of the month. The rest of the month, you're basically only paying a minimal amount for storage. Additionally, APIs or functions all of that combined together. You may even have the Azure API management on top of that to kind of expose some of this to developers outside your company or even clients outside your company. And you can then orchestrate your endpoints and give them a fully fledged page so they can look and see what API endpoints they can hit. You can obfuscate what you're doing behind the scenes. So in API management, you can actually call to a third-party API and you can inject things into the query strings or into the headers that they'll never know you're doing. So you can put things like a secret code that you have to access the secret API that you're actually paying for and then reselling to them through your API. And ultimately, they just say they're getting it from you, but you're actually getting it from you and someone else. And you combine all that and they don't even know it. So that's really cool stuff. It gives you a lot more flexibility as well. So if something goes down, you can easily fix that one little piece, or you can fix a process much more quickly because you don't have to deploy an entire monolith in order to get that out there. You have event handling that's extremely robust. You can put things into the Azure Event Grid, essentially do things like if I drop a file in storage, trigger my Azure function. If someone sends a message to Service Bus from one application, have all the subscribers respond to that. Or to the Service Bus queue, perhaps we only have a queue. So you get at most once or at least once delivery guaranteed, depending on what your scenario is. Big data scenarios, of course, have become incredibly important. Azure Data Lake Storage gives us the ability to store massive amounts of data in a hierarchical data structure, which we can use for analytics. On top of that, we have the Event Hub and the IoT Hub, which allows us to stream millions of records per second into our data scenarios. We can then use analytics on top of that, machine learning, cognitive services. There's endless possibilities to get things built. And all this is done in the serverless world. You don't have to do a lot of things to get these to work. You just provision the specific resources and make sure they can talk to each other and write the orchestrations around that. So a couple of the serverless tools that we want to be fully aware of. Azure Functions, you can have consumption plan, again, burstable, only use what you pay for, or you can have an app service plan, which is always on, warmed up, constantly working. You do pay for pre-provisioned compute power. So if you don't use it, you're still paying for it. You can have traditional Azure Functions, which are supposed to be short running, less than 5 minutes, and stateless. Or now you can have durable functions. Unless you're using Java, Java does not allow for durable functions at the moment. However, every other language does, as far as I'm aware. And the durable function allows you to do things like orchestration, chaining, monitoring events. You can have the full orchestration written in code in Azure Functions. Every serverless thing that we do typically has a trigger. And so they typically have the same kinds of triggers. It might be just an HTTP endpoint web trigger. It may be a scheduled trigger. It may be an event-driven trigger, like, again, dropping something in storage or something arrives in Service Bus. It may be external, such as a tweet on Twitter that we're monitoring with a hashtag. It may be something like a Twilio message got sent, or we may actually use that to trigger some code happening. We have all that happening in the Azure Functions as well to get them to start. All of those ways can kick off the function. The bindings means I can connect and work with different Azure services without writing the plumbing code. Cosmos DB, storage accounts. If I bind them on an input, meaning that I'm going to pull from them, or an output, meaning I'm going to write to them, then I don't have to write the plumbing code. Now, I can still write the plumbing code. If I don't want to use a binding, that's fine. I can create a connection using the SDK and set up my connection string and write code all day long to work against Cosmos or storage or whatever else without any bindings. But if I want to make it easier on my life, I can bind them in the Azure Function declaration, and then I don't have to wire up the function SDK code to actually do the plumbing. I can just write to it or read from it. All the popular languages are supported. So if you're using Python, Java, JavaScript, PowerShell, C#, .NET, whatever, it's all out there. Azure Logic Apps are a low-code orchestration. And if you've used Flow in BI, it's very similar. Ultimately, Logic Apps is a tool that allows someone who doesn't even really want to write a lot of code to build a very, very powerful orchestration. This orchestration, again, will have triggers just like an Azure function. Could be event-based, could be scheduled, whatever it might be. All that's available to the user. Now, with that, you also have the ability to use connectors and actions that allow us to connect to external things. There's over 200 connectors. You have the ability to respond to different things in the world. It could be, again, a hashtag on Twitter, or it could be, again, an event in the event grid. And then once you hit the connector, you're going to connect to maybe Twilio and send an email, or SendGrid and send an email, whatever it is. You have the actions that you're hitting that actually do things, and then the conditions. You can use conditions and loops to build even more further logic. You can trigger other Azure functions, other logic apps. You can hit any endpoint. You can post something to your Teams or your Slack channel. Everything's possible with an Azure Logic app, and it's all orchestrated, very low code. The event grid is the biggest piece of the puzzle for making things happen. This is the backbone that enables event-driven reactive programming. It uses the pub-sub model. Publishers emit the events and have no expectation about how they're handled. Subscribers decide on which events they want to handle, so you can filter by subject. Event Grid is deeply integrated with Azure Services. Again, we can create subscriptions to respond to things in Azure across services. It efficiently and reliably routes events from Azure and non-Azure resources, distributing the events to registered subscriber endpoints. It isn't a data pipeline. It doesn't deliver the actual object that was updated. It basically just is kind of the way to tell you that something happened. Here's the event with a little bit of metadata about that, maybe a file URL. There are some different key features of Azure Event Grid that you can use. You can do advanced filtering on the subject. You can fan them out, subscribing to several endpoints of the same event. You can have reliability, of course, built in. You have pay per event, so you only pay for what you use. You have a high throughput, so you can have millions of messages going through. You have built-in events where you basically just respond to it, such as dropping a file and storage account. You create a subscription with a couple clicks of a button. And you can even do your own custom events. Finally, DevOps and CICD. So when we talk about DevOps, we're talking about making our code happen automatically for deployment. And this is the biggest piece of the puzzle to ease the burden on your developers that you can possibly implement. Because what happens is this means as soon as I get my changes made, I can push them into my repository, and my repository can build the code, run unit tests, run static code scanning, can also publish things to the artifact repository or pull the dependencies from NuGet or NPM or whatever I need. It can run unit tests. It can run other automated tests to ensure that things are going to work. It can do penetration scanning to make sure that I have no security vulnerabilities. And we can identify those problems as early as possible and fix them. By the time we're moving into production, we should have very little concern that any of that stuff is wrong. The only concerns will be, did we implement a bug? Or, ultimately, is this doing what we thought it should do? So we would put all this into our pipelines, and ultimately the pipeline runs every time you hit a specific trigger, whether that's a push to the main branch or maybe it's a pull request opened on the main branch. So maybe you run one process during pull request review, and once it's actually pushed, you run another one to actually deploy it, right? So there's all kinds of options and configurations you can do. Typically, the pipelines are going to be written in YAML. They'll be triggered at events at the repository, again, checking code in or opening a pull request. You can also manually trigger them. So at GitHub, you do secrets. At ADO, you use variables. Either way, you can access and leverage those from your pipeline to make sure that you can obfuscate from the code or the pipeline specific things like potentially user passwords or settings. Those can be done in secret variables. Pipelines do get broken down into sections. You can have jobs, which can share one agent, or jobs can have their own. So whether you want to run on Windows or Ubuntu or some Mac processor, you can do that. You can have one job doing Windows, one doing Ubuntu, or you can have them all running on Ubuntu. Doesn't matter as long as your code compiles. You have steps within the jobs, then it determines what you're going to do. Check out the code, go ahead and build it, publish it, upload the artifact. Those are all different steps. Within the steps, you have each task. Once you have that out, you can do things like leverage the components, like Azure deploy or run a command, which you actually issue a bash command or a PowerShell command in your pipeline. Ultimately, once that's in place, you automate your deployment and everything at the push of a button is able to be deployed, and you don't have some of those concerns you had earlier on where only one person knows what's going on, or I'm going to push and pray and hope this works. All right, and so that's going to wrap up our talk on app modernization today. Ultimately, we started out by talking about traditional architectures. We talked about how you can plan and move your migration, some of the benefits, and then we looked a little bit at the different Azure Platform services available, Microservices architecture, and the serverless architecture that we can use, kind of some of the benefits and drawbacks of each of those, and we wrapped up with a look at DevOps. But ultimately, I'd like to thank you for attending the talk on app modernization here at the Azure A to Z conference for Skill Me Up Academy and Opsagility. Once again, my name is Brian Gorman at BL Gorman on Twitter, Brian L. Gorman on LinkedIn. I'd love to connect with you. Thank you very much. Enjoy the rest of your event.